I'm facing a challenge. I need to use scikit-learn's ColumnTransformer to prepare my data. My data has numbers, AGE, INCOME, categories, CITY, GENDER, and text, DESCRIPTION. I need to figure out the correct way to use STANDARDSCALER for numbers, ONEHOTENCODER for categories, and TFIDFVECTORIZER for text, all within the ColumnTransformer. This is my dataset. It's a pandas data frame called DF. This column holds numerical data representing age. This column contains numerical income data. This column contains categorical data representing city. This column holds categorical data on gender. This column contains textual descriptions. This is option A. I'm applying STANDARDSCALER to AGE and INCOME, numerical. I'm using ONEHOTENCODER for CITY and GENDER, categorical. And I'm using TFIDFVECTORIZER for the DESCRIPTION column, text. Means any other columns are ignored. This is a good option. Option B is missing the text processing step. It doesn't handle the DESCRIPTION column. Option C uses the column index 0 for the text data. This is risky because if the order of columns changes, the code will break. It's much better to use column names instead of indices. Option D uses column indices, 0, 1, 2, 3, 4. This is also fragile because if the columns move around, the code will likely fail. Using column names is safer and easier to understand. This phrase introduces the core topic, using scikit-learn's ColumnTransformer to effectively prepare data for machine learning. It's all about getting your data ready. I'm setting up a machine learning problem. We have a pandas data frame. That's a table of data, with different kinds of information, numbers, categories, like city or gender, and text. The goal is to use a special scikit-learn tool, ColumnTransformer, to clean and organize this data before I train a model. This is a numerical feature, meaning it represents a quantity, and it is a column in the dataset. Another numerical feature, similar to age, represents a quantity. This is categorical data, a column representing categories, different cities. Also categorical data, representing categories, male, female, etc. This column contains text data. It's different from numbers and categories. This is option A for solving the problem. I'm using ColumnTransformer to apply different transformations to different columns. For example, I am using STANDARDSCALER for age and income, numerical. ONEHOTENCODER is used for city and gender, categorical. TFIDFVECTORIZER is for description, text. Backquote remainder equals drop. Backquote means that any other columns in the data frame that are not mentioned are ignored. This is option B. It's similar to a but leaves out the text data processing step. It also uses backquote remainder equals pass through. Backquote, meaning columns not explicitly transformed will be passed through unaltered. Option C tries to use column index 0 for the text column, which is risky. If the column order in the data frame changes, this will fail. It's safer to use column names. Option D uses numerical indices 0, 1, 2, 3, 4 for columns instead of column names. This is fragile because if the data frame's columns get rearranged, this whole thing will likely break. It's generally best to avoid this method for its lack of robustness. I use the scikit-learn ColumnTransformer to prepare my data. It lets me apply different cleaning steps to different kinds of data in one go. Think of it like a data assembly line. I use this to change text data into numbers that my machine learning model can understand. It looks at how important each word is in the text. TFIDF stands for Term Frequency Inverse Document Frequency. I use this to make my numerical data have an average of 0 and a standard deviation of 1. This is called standardization, and it helps my model work better. I use this for categorical data, which are things like city or gender. It changes them into a numerical form by making one-hot encoded vectors for the categories. This is a number, specifically a person's age. I'll use standardscaler to process it. This shows a person's gender, e.g., male, female. I'll use onehotEncodER on this. This is a person's income, another number. I'll also use standardscaler to process it. This is a categorical variable showing a person's city. I'll use onehotEncodER for it. After I use onehotEncodER, my categorical features are transformed into numerical representations that my machine learning algorithm can handle. This is my data after I've cleaned and transformed all of it. It's ready for use in a machine learning model. These are my numerical features after standardscaler has transformed them, making them ready for my machine learning model. This is a placeholder. There is nothing specific referenced here related to 17. These are the text features after I use the TF-IDF-VECTORIZER, and are ready for machine learning. I use scikit-learn's ColumnTransformer to pre-process data with different feature types. It's like a toolbox that lets me apply different tools, transformers, to different parts of my data. For example, I might want to scale numerical data and encode categorical data separately. ColumnTransformer helps me organize this process. This refers to my data. It's stored in a pandas data frame, a convenient data structure for organizing and manipulating data in Python. Think of it as a spreadsheet. I'll use this data frame, which I call df as input for the ColumnTransformer. This is a numerical feature in my dataset. age is a column representing people's ages, which are numerical values. Similar to age income is another numerical feature. It represents income values, which are numbers. This is a categorical feature. city represents city names. These are not numbers but rather categories like New York, London, etc. I'll need a special technique, one-hot encoding, to handle these. Another categorical feature, gender indicates categories like male, female, or others. Like city I need to handle it with one-hot encoding. This is a text feature. Description contains text data like descriptions of items or people. To use this text in machine learning, I need a special technique called TF-IDF vectorization to convert text into numerical data that the machine learning model can understand. This is one of the ways I can configure the ColumnTransformer. I am defining how to process each column of my data by name. This line creates the ColumnTransformer object. It defines 3 stages. Num, for numerical features using standard scalar cat, for categorical features using one-hot encoder and text, for text data using TF-IDF vectorizer I'm applying the appropriate transformer to each feature by its name. Remainder equals drop. Means I'm discarding any extra columns. This option is incomplete. It's missing the text data processing component. This option attempts to use column indices, 0, instead of column names for text processing. While functional in some cases, using column names is safer and more readable because it's not dependent on column order. This option uses column indices, 0, 1, 2, 3, 4. This is risky because it depends on the data's column order. If the order changes, this code will fail. Using column names is the better practice. I use standard scalar to transform numerical features, like age and income. It centers the data around 0 by subtracting the mean and then scales it by dividing by the standard deviation. This makes sure that all numerical features contribute equally to the model, preventing features with larger values from dominating. I use TF-IDF vectorizer to convert text data into numerical vectors that machine learning models can understand. It calculates term frequency inverse document frequency, TF-IDF, scores for each word. TF-IDF measures how important a word is in a document relative to a collection of documents. Words appearing frequently in a single document but rarely in others get higher scores. I employ one hot encoder to convert categorical features, like city and gender, into numerical representations. It creates new columns, one for each unique value in the categorical feature. Each row gets a 1 in the column representing its value and 0 in all others. This helps the model interpret categorical data. I'm working with a pandas data frame called DF. It contains different data types: numerical, categorical, and text. Think of it as a spreadsheet, but much more powerful for data analysis. After I apply the transformations, I get pre-processed data ready for a machine learning model. It now consistently represents numerical, categorical, and text data. This uniform format is vital for creating effective models. I'm looking at how to correctly set up a ColumnTransformer in Sklearn to prepare my data. I need to handle different data types using the right tools. My data is organized in a pandas data frame, which I'll call _df_. This is a common way to work with data in Python. These are my numerical columns. I'll use _standard scalar to make them have a mean of 0 and a standard deviation of 1. This helps many machine learning algorithms work better. These columns contain categories, like city names or genders. I need to use one hot encoder to transform them into numerical representations. For example, male and female might become 1, 0, and 0, 1, respectively. This is my text column. I will use _TF-IDF vectorizer to convert the text into numerical features that reflect word frequency and importance. This is a common technique in text processing. This is a scikit-learn tool I'll use to scale numerical features, making them have zero mean and unit variance. It's like adjusting the brightness and contrast of an image. This scikit-learn transformer converts categorical features into numerical ones. It's like creating separate binary flags for each category. This scikit-learn tool is used for converting text into numerical features. It weights words based on their frequency in the document and the entire corpus. It's like highlighting the most important keywords. This is the result after applying the ColumnTransformer. It's my dataset ready for machine learning. Great job. This describes the overall problem. I need to choose the right scikit-learn ColumnTransformer configuration. A ColumnTransformer lets me apply different data transformations to different columns of my data. I'm working with a dataset stored in a pandas data frame, which I've conveniently named _df_. Pandas data frames are a common way to organize data in Python. This introduces the different types of features in my dataset. These are my numerical features, meaning they contain numbers that are meaningful for calculations. Specifically, they are age and income. These are categorical features. They represent categories or groups, like the city someone lives in or their gender. This is a text feature. It contains free-form text. Think of this as, for example, a product description in an e-commerce database. This is option A. I'm using a ColumnTransformer court to process my data. I apply standardscalar to my numerical features, age and income, onehotencoder to categorical features, city and gender, and tfidfvectorizer to the text feature, description. The remainder equals drop part means I'll ignore any other columns in the data frame. Option C. This is similar to A, but I'm using a column index, 0, for the text feature instead of its name, description. Using column indices is risky, as it would fail if columns are reordered in the data frame. Also, the remainder equals pass-through part here means any extra columns will be included in the output without modification. Option D. I'm using column indices, 0, 1, 2, 3, 4, here. This is even more fragile than option C. If the column order changes, this will fail completely. It also uses remainder equals pass through, backquote.